Welcome to today's lecture in our Absolute Beginner's Intro to Computer Programming class. We have spent the last couple of days laying the groundwork on the information technology landscape, and it's time to zero in on software. Today we will be starting from the very beginning, so let's get busy. Humans have always been explorers. As a race, we are constantly extending frontiers. So when we became bored with the physical world as we've always known it, we decided to build a whole new civilization for ourselves in the virtual world, facilitated solely by computers and made widely available through the interweb, the interconnected network of computers which we call the internet. There is absolutely nothing we do in the physical world that cannot be done in the virtual world. Education, business, healthcare, social interaction, even crime. Yes, we have completely perfected living life in our virtual existence and we are thriving. Whether that is good or bad for our species is another video entirely. Why we are here today is to point out that just like the industrial age, we will always need people to continue the construction, enhancement, management, and maintenance of this new civilization. That is where you come in. Before we start with our objective of learning how to program databases, there are a few concepts and terminologies we all need to agree on. Because this is an absolute beginner's intro, I want to make sure we are all on the same page about certain terminologies you will come across in your career as a software developer. First on the list is a computer. What exactly is a computer? Odds are if you grew up about the same time as I did, this would have been a very simple question to answer. A computer is simply that big box in that controlled air-conditioned room that adults rarely allowed you to access. Gradually, thanks to the folks in Microsoft, a computer became synonymous with the PC or the personal computer, including desktops and laptops, as homes and offices could now own this mega toy that could do almost anything. Fast forward to the internet age, and this same question, what is a computer, is not that simple anymore, as almost anything humans use for every single task could potentially be a computer. So, what is a computer? A computer is an electronic device that can be programmed to carry out a set of logical instructions. In this definition, three things become important to qualify anything as a computer. First, it has to be powered by some form of electricity, that is electrical energy. Second, you should be able to feed it some type of instructions called programs. We'll talk about this in detail shortly. And finally, this device should be able to carry out those instructions perfectly, allowing you, the puppet master, to achieve the intended task. Armed with this new knowledge about what qualifies as a computer, take a few minutes to look around you. See if you can come up with 10 devices in your home that will qualify as a computer. Actually, pause this right now and take about 3 minutes to look around you. I'll wait. Yes, the desktop and laptops are computers as well as the mobile phones currently in your pocket. How about your gaming consoles? Those are also electronic and they have been programmed to allow you to play games, surf the internet, and collaborate with friends. This makes gaming consoles computers as well. With Internet of Things (IoT) technology, those household electronic devices, including your smart refrigerators, washing machines, ovens, wristwatches, Fitbits, etc., Even your modern cars are all computers. Looks like everywhere you turn these days, computers are all around you. You're still wondering why there's such a frenzy about computers taking over the world? Can you spot more computers around you that you otherwise wouldn't have paid attention to? Remember, if it's electronic, can be programmed, and carry out those logical instructions, it's a, let's all say it together, computer. Now that we know what a computer is, what do we mean by a computer program? Before we define what a computer program is, have you ever used a calculator on your phone or on your PC? Have you ever sent an email, written a letter, school paper, to-do lists, etc. on a word processor? Example, Microsoft Word or Google Docs. Have you ever browsed the internet, used social media sites including Facebook, Twitter, now X, Snapchat, Instagram, WhatsApp, etc.? At this point, I'm sure you are saying to yourself, who hasn't? And you'll be correct. The calculator on your phone or PC, email, word processor, browser, social media, and lots more are all examples of computer programs. A computer program is a set of instructions that a computer follows to complete a task. Let's think about it for a minute. Someone or a group of people wrote a set of instructions that would allow calculations to be done on either your PC or your phone, so that whenever you wanted to quickly calculate anything, all you need to do is whip out the calculator program and calculate away. You can substitute any type of computer program for the calculator example above and it will still be true. So, a computer program is a set of logical instructions that a computer follows to perform a particular task. This means programming a computer or computer programming is writing those set of instructions that tells a computer how to do what you are requesting it to do. Most times, those set of instructions are detailed step-by-step instructions that a computer can follow in order to accomplish the task that it needs to do. If we revisit those group of people that wrote the calculator program, we would appreciate that computer programming is all about using your imagination and creativity to bring ideas to life with the help of a computer. One word you will hear used as a synonym for computer programs is software. Conceptually, this may be allowable to a certain extent, but once you dive below the surface and observe how both computer programs and software are created, very important distinguishing features become observable. Creating computer programs, what we refer to above as computer programming, that is, writing the logical instruction for the computer, also called construction. We will borrow quite a few metaphors from the engineering world. Takes about 30 to 80% of the process of creating software, referred to as software development. We can therefore say that while writing computer programs is a sizable part of software development, it is not all of it. Another way of saying this is computer programming, also known as construction, is a central activity in software development. Therefore, software development is a lot more than programming or construction or writing code. It is the process of taking an idea that will solve a problem through developing specific sets of requirements, formulating design and architecture, then constructing the design solution, testing that solution and releasing the solution to the end user population, including all post-release maintenance activity. While we will be primarily focused on writing computer programs in this course, that is the construction part of software development, wherever applicable, we'll discuss how this intersects with the software development process. Now that we know what a computer and computer programs are and what computer programming, well, also known as software development, is about, how do we get those instructions, that is the programs, into the computer so it can do its magic. This is where computer programming languages, or simply programming languages, come in. Odds are, if I start speaking a foreign language to you, you will simply keep staring at me and do nothing, including the oddly peculiar awkward look that would be plastered on your face. Same with the computer. You must speak the language the machine understands. The computer is a digital system, quite different from the analog systems that came before it. As a result, for a computer to model the real world, it needs to convert or map everything it does to digits, that is, numbers. So we can say the real OG language of computers is numbers. But here's the problem though. We humans don't speak numbers, do we? We speak in words. This means we need a system whereby we can represent our words or whatever we are trying to communicate with the computer into numbers. At its core, the numbers the computers understands are called bits. Bits are short for binary digits and consist of only two binary digits, 1 and 0. This is where the phrase computers only understands ones and zeros come from. Bits are the binary numbering system, otherwise called base 2. As humans, you are probably used to the decimal numbering system, or base 10, with 10 denary or decanary digits. We will have a lot to talk about how we translate our human language to the computer's binary language throughout this course. But for now, understand that the computer can only understand the binary language, and all computer languages has a system that lets it convert that particular programming language to the computer's binary language. A single bit, that is either the 1 or the 0, cannot convey much information. It's either 0 or 1, off or on, true or false, male or female, wrong or right. Because you can only represent two different values with bits, bits by themselves are not sufficient for most computational needs. We therefore need sequence of multiple bits. Most computer systems don't let you combine an arbitrary number of bits. Therefore, you have to work with a sequence of bits of certain fixed length. The most important one we will consider here is the byte. A byte is 8 bits and it's the smallest addressable data item on many computers' central processing units. This means that the CPU can efficiently retrieve data in groups of 8 bits from memory. There are many computer languages. You will hear about low-level computer languages such as assembly language, so-called because they are written in code very close to the computer's language of binary and are not human readable. High-level languages including C, C++, C#, Java, JavaScript, Python, SQL, etc. These languages are human readable languages designed to be written in as near English as possible. This makes it easy for us mere mortals to communicate with the computer by giving it instruction of what to do. High-level languages have a system including compilers, interpreters, etc. used in converting their near English instruction to the computer's binary language. We won't worry too much about computer language classification here, but understand that the different languages have specialized uses and you pick a language based on the task at hand. Well, mostly. Examples of popular programming languages include JavaScript, being the language of the web. Websites and web applications are written mostly using JavaScript. Python is specialized for data analytics, machine learning because of all the useful libraries that comes with it. And SQL, which is our major focus in this course, is highly specialized for programming databases. As this is an introduction to database programming course, the computer program or software we will be designing and constructing will be targeted at database solution, and our programming language will be the structured query language, otherwise referred to as SQL. You could either sound out each of the letters as in S, Q, L, or say SQL, its unofficial street name. SQL is a highly versatile, declarative, high-level language used to program databases and is well suited for beginner programmers because of the easy to navigate learning curve and the non-complicated development environment. The programming skills learned programming SQL are easily portable to other programming languages. The next set of terminologies we will consider would be those related to databases. The logical place to start is to define the term data. Without data, there won't be a need to program databases. I am sure you've heard at some point that data is the new gold. We will investigate the validity of this statement later in the course. For now, what is data? Data in a nutshell is any observable fact. This means nearly everything is data in a way. As a person, data about you, that is, observable facts about you, include your name, age, gender, etc. A thermometer can be used to measure temperature over a period of time. The fact being observed here is temperature, and as such, temperature is data. Companies need to keep tabs on their employees, inventory, products, revenue, etc. As you may have guessed, employees, inventory, products, and revenue in the context of business organizations are all examples of data. Data has become so prevalent in our society these days, and in fact, there are companies whose entire business models center around management of data. No physical products, just data stewardship, and they are among the most profitable on the planet. Think Facebook. As a result, you can define data as a collection of facts, such as numbers, descriptions, and observation used in decision making. There is an abundance of data in our planet, and as a matter of fact, human beings have found ways of accessing and making sense of data from outside our planet. Right now, there's a man-made rover on Mars collecting and sending observable facts, that is data, back to Earth. Raw data usually doesn't have value. However, when meticulously collected and analyzed properly, data provides a wealth of useful information and informs critical business decisions. Properly analyzed data yields information that the business usually accumulates to yield knowledge that it can use to be a differentiator, allowing businesses to increase their profitability. You should start building your evidence for or against data being the new gold for both individuals and businesses. I don't mean to be grim, but right before recording this lecture, I went on data.gov and was surprised to see data on death rates for suicide by sex and race in the United States from 1950 to 2020. I decided to do some very rudimentary preliminary data analysis, and what turned up shocked me. The insight pointed to a high level of suicide in male, the solid red line, but the shocker is the higher rate in white male, the solid green line. Clearly, going forward in my sphere of influence, I'll be paying more attention to mental health, especially in white male. But my interest is clearly piqued by what the data turned up, and my work continues with this data set. The point I am trying to make is that data leads to actionable insights that an enterprise should use to improve its bottom line. Let's get back on track with a small exercise. Think about the data you generate or interact with daily. You probably have a set time you wake up every day. You have routines you do, which may include your shopping habits. Most of this data on its own means little to you. It's even become commonplace that you don't really consider it data. Now, think about how you submit all that data to a business, let's say Facebook, by yourself for free. By using any Facebook's platform, which includes WhatsApp, Facebook, and Instagram. Facebook collects, accumulates that data, processes and aggregates it, and makes you a product that can be precisely targeted according to your taste and preferences by their advertising clients. Last I checked, Facebook is a $500 billion company. Data could be structured, semi-structured, or unstructured. Let's dig deeper into this classification as this would form the foundation of everything we will be studying in this course. Structured data. As the name suggests, there is a structure to the data at play here. This means that across the board, the data considered will have the same properties for every entity. An entity is any tangible object, animate or inanimate, that participates in running your business. The technical term for this is that the schema is fixed. Because structured data adheres to a fixed schema, it is straightforward to enter, query, and analyze. You will hear structured data referred to as relational data because data in one entity usually has a relationship to data in another entity, and as a result, the structured query language SQL is excellent in interrogating this type of data. Structured data is where we will be spending a lot of time in our course. Applications such as customer relationship management, CRM systems, reservation and inventory management systems all thrive with this data. Semi-structured data. This type of data is less organized than structured data. They are not stored in relational formats because their schema is not fixed. They are also referred to as non-relational or NoSQL data. NoSQL has been retrofitted to mean not only SQL. And there's a story there that we may discuss before the end of this course. The next time you send an email, take a look at the compose new message screen. It has some fixed properties, schema, including the recipient, copy, subject. The body of the email is usually free for all. This mixture of both structure and no structure is an example of semi-structured data. Technologies that can handle semi-structured data excellently includes XML, Extensible Markup Language, JSON, JavaScript Object Notation, and YAML, YAML in Markup Language. Unstructured data. This includes all data with no designated structure to it. This lack of structure means there are no restrictions on any kind of data it can hold. Examples of unstructured data includes your media files such as photos, audio and image files, office files including Word documents, text files, log files, etc. As we progress in our discussion to databases, which essentially is where our data will live, keep this data classification in mind because the classification will determine the type of database that will house the data. That is structured, relational data stored in relational databases, semi-structured, NoSQL data stored in NoSQL non-relational databases, and unstructured data stored in binary large objects or blobs. Okay, so we have come to the point in our course that we can safely be introduced to databases. What are they? Before we define databases, have you ever seen a military base? Either you have visited one, lived in one, or seen one in movies. What's in a military base? Military people. Now, get back on track. What do you think would be in a database? You see what I just did there? Okay, now that we have kind of a general idea of what a database is, let's look at the fancy definition. A database is an integrated collection of logically related data elements that consolidates records previously stored in separate files into a common pool of data elements that provides data for many applications. All that just to define base for data. Well, now you know. You store data in a database, and sooner than later you will request that data back from the database, either for examination or analysis. Therefore, a database must have a system to ensure access to and retrieval of its data is as seamless as possible. Imagine if you store data in a database and when you need that data you can't access it. That wouldn't be nice, would it? To ensure this seamless storage and retrieval of data, we need some sort of database manager that will oversee this process and ensure it works as perfectly as possible. We do have such a database manager, and it is called the Database Management System, or DBMS for short. A DBMS is an application software that allows us to work with a database and its data, including any relationship. The functions of a DBMS includes creating and changing the database structure, adding and deleting data, retrieving data. A DBMS is accessed from an application program or user interface. We said earlier that we will be focusing on structured data in this course. We learned that structured data is also referred to as relational data. As a result, the database we will be studying are relational databases, and our database management system, DBMS, would be a relational database management system. There are many RDBMSs in the marketplace today. They range from proprietary ones, which means you have to pay to use them, like Microsoft SQL Server, Oracle Database, IBM DB2, to open source ones, which means they are available for free, like PostgreSQL, MySQL, etc. For this course, we will be using the Microsoft SQL Server Relational Database Management System. Now that we have squared away some very important definitions in our software programming journey, the next logical step is to get to work. To do that, we need two important software, which will be the tools that gets us started in our programming career. First software would be our Relational Database Management System. Above we said we will be using the Microsoft SQL Server as our RDBMS. This means we will have to install this software on our computer workstation. The Microsoft SQL Server version we will be using is called SQL Server 2019 Developer Edition. This mirrors the version of the RDBMSs that enterprises use to manage their database infrastructure. Therefore, learning to use SQL Server 2019 Developer Edition puts you way ahead of the curve in your learning journey. SQL Server 2019 Developer Edition is a server software. The second software we will be installing is called SQL Server Management Studio, fondly referenced by its acronym SSMS. Unlike SQL Server 2019 Developer Edition, SSMS is a client software. It would be the main application that we will be using to connect to and work with our server software, that is SQL Server 2019 Developer Edition. This combination of tools models a very important software architecture called the client-server architecture, which we will be discussing as we progress. For now, our goal is to install both our server and client software on our workstation. Instructions to do so will be passed to us via email. Therefore, your assignment for this lecture, and yes, you have assignments, will be 1. Review the materials in this video and ensure you understand. Note down any question you have for our weekly discussion. 2. Install your server software, SQL Server 2019 Developer Edition. And 3. install your client software, SQL Server Management Studio, SSMS. Good luck.